Hello, I'm Mrs. Suggs, and I'm going to be doing the clock reaction with you. This is called the iodine clock reaction. I'll talk to you more about the details in our pre-lab on Tuesday. But here is the video I am making for your collection of data that you'll view on Wednesday. Now, in the handout, it said I was going to be using 10,98765 mils of solution A. I have doubled that so that you can see a greater volume. I am going to be putting the volume of A on a Post-it here on my lab coat. This is 20 mils of A with no water and 20 mils of B. The decimal is always 0.0. I've measured these very carefully. I am going to say 1, 2, 3, pour. 1, 2, 3, pour. And you'll have to time when the reaction turns black. So here we go. 1, 2, 3, pour. All right. Next reaction. This is 18 mils of A and 2 mils of water with the same 20 mils of B. 1, 2, 3, pour. I'm mixing them so that you are sure to have a homogeneous mixture here. Sixteen mils of A with 4 mils of water. 1, 2, 3, pour. I love this reaction. 14 mils of A with 6 mils of water. 1, 2, 3, pour. Mixing, making sure it's a homogeneous mixture after I added 2 different solutions. Twelve mils of A with 8 mils of water. 1, 2, 3, pour. Gotta get away from the computer. Ten mils of A with 10 mils of water, still 20 mils of B. 1, 2, 3, pour. Okay. And the last one, 8 mils of A with 12 mils of water. More water than solution A. 1, 2, 3, pour. Try to notice the consistency or the way in which it turns blue. Let's make sure the blueness is arriving in a consistent way. Okay. Do you see how it took a little longer to travel through the solution at that level of dilution? Now I'm going to pause the video and go get my 5 temperatures. I'll be right back. All right, I have my 2 cold temperatures here. This solution is 15.0 degrees Celsius. 15.0. I'm going to pour them both into a flask and then swirl the flask. So you're going to be looking at this one a little differently. 15.0, 1, 2, 3, pour. 15.0 degrees Celsius. All right. Now this is 6 degrees Celsius. 6. 6 degrees Celsius. Yep. I'm going to pour it into the flask also and swirl. 1, 2, 3, pour. All right. This is going to be my room temperature. So let me get that temperature for you. Just a minute. Room temperature is always around 20, but as these are being measured, this room temperature is 21.5. 21.5 degrees Celsius in the room. Room temperature solutions of A and B. 1, 2, 3, pour. All right, I'll pause the recording while I go get the hot temperatures. All right, I've got 2 hotter solutions. All these solutions at temperature variations are 20 mils and 20 mils of A and B. This is at 35.5 degrees. I had it in hot water. I am pouring these into a beaker and then swirling. 1, 2, 3, pour. All right. And these other hotter solutions are at 45.0 degrees Celsius. I will also pour them into beaker to pour them quickly and then swirl. 1, 2, 3, pour. All right, there you have the data that you can record in your data table, eventually do calculations with, and plot a graph of how the concentration of solution A is impacting the rate of this reaction. Thank you. We'll talk more about this video in class. So I'll say goodbye, and we'll talk about this either before or after you actually record the data. Thank you.